Alright, how's it going, people? So today we are going to implement the McCarthy 91 function. First we're going to discuss the recurrence relation, review the C solution given to us by Wikipedia, and then convert this thing into ARMv8 on an Amazon EC2 A1 instance. Alright, so as far as McCarthy 91 goes, this is just strictly an academic function. It was used just for like formal verification, so they're improving, I guess. So it has no practical purpose, but you know, it's just some arbitrary example of recursion. So the recurrence relation is the following. If you call McCarthy 91 with an argument of n greater than 100, return n minus 10. Otherwise, the recursive case, specifically in a situation where n is less than or equal to 100, it's a double recursive call to McCarthy 91, where first you call McCarthy 91 with an argument of n plus 11, and then the result of that, whatever's returned, is passed as the argument to a second call to McCarthy 91. All right? So, you know, you might want to just look at the Wikipedia page. I'm not really going to go over this because the purpose of this channel and this sequence of videos is really just arbitrary exercises in ARMv8. All right? So we're going to just accept this solution as given, which is the C code solution for McCarthy 91. All right, so this is the algorithm that we have here. It is an integer returning function. It looks like we only have one argument, which would be passed in W0. We have a base case, and as well, whatever this value is would be passed through W0. What will really help us here, though, is that the output of this McCarthy 91 needs to be passed as the input to a subsequent call into McCarthy 91 again, and thankfully with ARMv8 you end up using the same register for in and out, so that might save us a few instructions there. It could actually be that when we convert this thing to assembly that it ends up being simpler than what the C code would be. All right, so let's hop into the server now and see what we can do. All right, so what we're going to do here is we're going to use GCC to implement a simple template for us using printf, as well as the simple linkage for a main, because the main goal of this sequence of videos is really just an arbitrary exercise in ARMv8. We don't really want to get caught with all the trappings of having to call printf, setting a pointer for a string literal, figuring out what the linkage requirements are for a main function. All right, so let's just open up a main function and implement something here. We'll include stdio, of course, because we're going to use printf for our debugging. We will have a function called MC91, and its argument will just be a single argument. Now what we're going to do here is just set it to return 0, and then when we hop into the assembly, we will replace this return 0 with whatever code we need. All right. As far as our main function goes, it's not going to have any variable arguments. We'll just leave it like that. Remember, with the main, you always want to return 0, which is the code for exiting the process properly without any errors. And we're going to call printf and return the result of a call to McCarthy 91. The string token I'm using here for printf, %d meaning integer, /n meaning new line. And we're going to insert MC91. Let's try the base case here. So, you know, looking back to the, feel free to look back to the Wikipedia page, I guess. We'll start out with a base case. The base case is any value greater than 100. So I guess we'll do 101. All right. So that'll be our first case, and we'll test the base case with a value of something greater than 100. And a recursive case is any situation where it is less than or equal to 100. So if we pass it less than 100, that'll test the recursive case there. All right. Cool. So let's back out and use GCC to generate some assembly code. So the command you're looking for, GCC, display all warnings, don't optimize. Remember, capital S to generate assembly code. The output will be main.s, and we want to compile main.c, or rather translate. There's not really any compiling or linking involved at this state. All right, no errors. Let's go ahead and look at what main.s looks like, what GCC had prepared for us. As with the previous videos, remember, it's very important as a programmer that you have this skill where you're given some code that's not yours and be able to identify quickly the portions that are relevant to you, okay? So we need to find the start of McCarthy 91. Down here, start of main, we're just accepting main as given here and that we're not going to modify it. The thing we need to modify is the dummy McCarthy 91 function that is just returning 0, all right? And that's basically what it's doing there. So I'm going to just mark the starting point here. This will be the start of our McCarthy 91 function. And it looks like this will be the end. How do I know it's the end? Well, it looks like this is based on this compiler directive right here, it looks like this is the start of an entirely new section that is not text or instructions. So I feel like that's safe to declare the end of the function there. All right. So I'm looking at this thing. I'm not sure how much stack space we're going to need, but I am going to modify this thing to at least 64. I honestly don't know if we'll need 64 bytes, but that's just a safe number to use. Okay. So I modified the stack pointer up here, stack pointer movement instruction to allocate 64 bytes. Remember to modify the pop instruction to match the stack space that you had declared on entry to the function. Another concern that we have here is the stack alignment, as well as, so the first concern actually is, as with the calling convention, I'm going to want to store x30 and x29 just above each other at the bottom of our stack frame. So this alignment where we're shadowing the input n to stack pointer plus 12, I'm going to need to modify that. But let's set these first few instructions. So I'm going to set the return address to the bottom of our stack frame, and we're going to set the frame pointer to be just above that. And remember, x30 is 8 bytes long, so that means that the next valid space on the stack would be SP plus 8. All right, and that affects our shadow value of n because this was placed at SP 12. That means that x29 is 8 bytes long, so that occupies 9, 10, 11, 12, 13, 14, 15. So that means that W0 can no longer be stored at SP12 because it is actually clobbering, or rather inside what's considered the value for our frame pointer. So I guess, you just put it like after, so it's like x30 is 8 bytes, starts at stack pointer. Just above that is the frame pointer, starts at 8 bytes above that. And then the input value of n, just above that as well. And it is 4 bytes long. So what we're going to do here is any further stack space that's needed is going to need to be beyond SP20, although I don't think we're going to need it, but let's see. All right. So the next instruction we're going to implement is some comparison to determine if we should jump to the base case. All right, so if you're looking on the upper right here, what you need to do is compare the input to a literal value of 100. On entry to the function, you haven't modified W0, so it should still be contained. The value of n should still be contained in W0, so it's safe to just use W0 here and not refresh it from the stack. All right, so let's compare n to 100. We want to check and see if it is greater than. If that's the case, we need to return base case. I'm just going to call it ret base to be the start of whatever code block is responsible for returning the value in the base case. Let's go ahead and finish the rest of our code here. So that would be a nested call to McCarthy 91, where the first call is pass a value of n plus 11. All right. So how do you handle that? So basically, the best way to handle this is to basically break this apart, right? Because we're at the assembly level, and at C you might combine stuff to make it seem really elegant and stuff, but at the assembly level you really have to break it down to smaller components. So what happens here is you end up calling McCarthy 91 for the first time, and a second time calling McCarthy 91, but this time sending temp as the input argument and then returning the value of temp2. All right, so let's go through this one by one. So this first call, we need to call McCarthy 91, but this time to add 11 to the input argument. If you've arrived at this point, still, W0 actually still contains the value of n, so if you want, you could just add a literal value of 11 and then end up calling a branch and link to McCarthy 91. That seems pretty simple, and actually that's pretty much all we need to do. What happens is here, the value of temp will be stored in W0 because according to our calling convention, you place the result of the call into W0. All right? So where do we go from there? So we now need to call a second call to McCarthy 91 where we pass whatever temp was in W0, but so it looks like the result temp is actually already in W0. So you might try to do something like this where you're trying to move something into W0, but what do you do? It's already in W0 actually. So it leads to a very weird, perhaps confusing scenario where you literally just call McCarthy 91 twice, basically, because of this feature with ARMv8 where the input register is the same as the output register if you only have one input, okay? So yeah, so basically that means that temp2 should be placed in W0 for us, all right? Now we just need to return temp2, and again, W0 is the return register, so we actually need to do nothing. This call had already set up the result to return in exactly the register that we need, all right? So now we're at the return point. All right, and because this is a non-leaf function, remember to grab that value off the stack. So here we place the return address at stack pointer, and here we're going to refresh the value from stack pointer and place that into x30 so the return address is restored, and then proceed into our popping the stack and returning. One thing we're going to do here, we're going to label this whole point here as done so that the base case will basically jump to the done portion of code and then just be done with that there. All right. It'll limit the amount of instructions for our base case. All right. So let's go ahead and implement our base case here. And you know, I said this was the end. I think I'm going to suspect that that this right here is actually kind of important and a part of MC91. Must be some compiler directives, especially the CFI end proc. I'm going to go ahead and implement the base case just below the return. All right. Remember, we called this thing ret base. All right. So on the base case, what we need to do, we'll label this thing as ret base. We need to return n minus 10. All right. So what do we do there? So let's just check out how do you end up at ret base. So basically, you enter the function up here, and you compare W0 to 100, and then it jumps to ret base. Technically, the value of W0, if you end up over here, still contains the value of n. We did not modify it. This instruction to modify W0 only happens if you fall through into the recursive case. So if this is true, you end up over here with W0 still reflecting the appropriate value of n. So if you want to add, or if you want to subtract 10 to it, you can just sub W0, W0, 10, and then unconditionally branch to done so that the function then returns the, sets the return address, pops the stack, and then returns. All right. Okay, so that's pretty much that. Let's go ahead and compile this thing in GCC and make sure it works. All right, so I'm back here in GCC, display all warnings, don't optimize. This time we want an output main.out, no -s flag. We're actually compiling and linking this time. We're compiling from main.s. All right, cool. No errors. Everybody cross your fingers here. Let's try to run this thing. And so we get a 91 both for the base case and the recursive case. Does that seem right? Well, if we switch over to the Wikipedia page, the definition will point us in the right direction here. That's actually the correct response. Because if I scroll down here, it says that McCarthy 91 is equal to 91 for all integer arguments where n is less than or equal to 100. That first call, the base case, is 100. Therefore, it should return 91. And for any recursive case, m of n is equal to n minus 10 for all values of n greater than 100. So we passed it. We passed it 101. All right. So 101 minus 10 is 91. So there you have it. That's correct there. All right. So that's it for today, people. Subsequent videos are going to be on recursive Fibonacci, as well as binary search and merge sort.